In the spirit of demo day, I will demo. So what I want to talk about today, two things really. We're not going to do Start Plug B because Simon Young, who is the author of the Spark Plug B plugin, is not able to join us this morning. So I will be doing instead, I'll talk a little bit about some of the new capabilities we have with MQTT. MQTT support within MTConnect. And I'll also talk about Umati. And Umati is a plugin, and I'll talk about a little bit about plugins in general and how we're going to be supporting those. Some of the ones that are produced by Ontology. You can write your own, you can extend the functionality of the agent and do all kinds of fun things. So this is my video on. Hey, son. So let's just go at it. The easiest way to talk about um, the MQTT support that we have right now is actually just to fire it up. And the easiest way to do that is to go and jump onto Docker. People are familiar with Docker, there's a thing called Docker Hub. And Docker Hub is a nice place to keep your various images, and they're very easy to get. You just do a pull on it. So I'm going to come over here to the public view. It's a bit easier to see what you're going to see when you come in. And all you got to do to start MTConnect up is install Docker and then do a Docker pull MTConnect agent. That will get you the agent. And it's pre-built. It's running on an operating system called Alpine, which is a Linux flavor, and supports quite a bit of capability. So what you need to do to get it started, if you want to, let's say, take a look at quickly how to run the Mosquito MQTT server and MTConnect agent and a couple of adapters, is basically use what's called Docker Compose. Docker Compose takes multiple different images, pulls them all together, and then just fires them all up in order, and it manages dependencies and mountings and all kinds of things. So this is actually the file. It's not very complicated for starting the thing up. You can start up the Mazak simulator, the Kuma simulator, and I'll show it to you in a second. Mosquito, which is from the Eclipse Foundation, and then the agent. And this has a special configuration for it and everything else. So if you look at the agent right here, you can see the various different configuration files and the adapter files and so forth. So that tells you how to build it and all those kind of fun things. So let's just get this guy going. And again, this is a demo day, so I'm demoing. Docker Compose, nice. MQTT up. That's actually it. Once you do that, then you can go check and see if it's working. And it is working. So what we can see here is the two machines. So, this is the agent device, of course, the Akuma device, and then we got the Mazak here someplace. I keep going on. Lots of data. This is the full demo. Of course, this is the digital twin demo. So if you were to go to twin, like you can look at like the Mazak, or you can look at the Akuma. And again, this is running in Docker right now. This is the thing that I just started up for you. I did tell you about MQTT, so let's go do that. So we have a little local thing here. So this is actually the Mosquito that's running inside of that that Docker inside of a Docker container for Mosquito, which is actually the standard Mosquito image, nothing that we even had to build. And as you can see, it's running. This is MTConnect. And we have a few different things here. So we have the agent device, we have the Akuma. These are the probes. This is a new MQTT2, which is basically the second version of the MQTT support that we have. The first version had some issues because we were doing one topic per data item / observation, and that was overloading the broker. The MTConnect agent can actually publish a huge amount of data very, very fast. We found that too many topics, too deep topic length caused all kinds of problems with the broker when we loaded it up. And Stratasys had some issues, and some other companies had some issues with this. So, given that, wanting some of these outside. So, given that, we decided to change things up a little bit and go to a format that allowed us to have MQTT publish in a very similar way to a REST interface. So we have the probe, the current, and the sample, and assets. So we have the 4 main categories of request. There's one additional one that I just added. Actually, this is just as of yesterday. I need feedback on this, by the way. And this is the availability. Availability is, if people know MQTT, it's the last will and testament. This is my last will and testament for this agent. And when the agent disconnects, this will automatically go to unavailable. So we have last will and testament now. So the next piece of it is basically the agent will publish to the current every 10 seconds. And it will publish the latest data, the current, the snapshot of all of the data items for each of these devices every 10 seconds. If you just want slow rate data every 10 seconds, you can just subscribe to the current for this particular device. If, let's say, you wanted all the changes as they're happening, what you would do is you would actually subscribe to the sample, start getting some data coming out, subscribe to the current, and the current in the header, I'll show this to you in a second once it renders here, will tell you where to start. So it'll say that the next sequence is 5241. And then if you're getting the samples, you say, okay, I'm going to discard everything before that current and then start applying the deltas from the samples. The samples are going to come out about every half a second. If there is a change to any data items within that device, it will publish to this topic for the device, or whichever the device name is, Mazak or Akuma, and it will publish to that device, and just the changes from the last time it published. As you can see, there's a small set of data. You can see the next sequence number right here. And again, if you just keep getting a stream of data, you can apply those to the current and have a contiguous set of data, never miss a beat, and get every single change that occurred. That's what the samples give you, every single delta. The currents give you snapshots. And then, of course, we also have the assets down here. So we have a bunch of assets here, and the assets are going to be those asset models that we can see. A second. Just got some more in. This tool gets a bit slow. Again, we're publishing, so. Okay. This thing coming up. Oh, there it goes. Okay, got it. So this is our cutting tool data. Just taking a while to come up with all the topics. So each one of the assets published to its own topic. We get the data coming out here. And again, all these guys are retained, so you can go and grab them even after shut down. And that's all the cutting tool data. So we have the probe, which is your metadata about describes the device and all the bits and pieces of it, all in JSON. That also is enough data to allow us to do what I showed you before, the digital twin, the currents and samples, the deltas, and of course, the assets. And again, that was started pretty much by just doing a compose up. So I'm going to shut this guy down. Again, to get the latest version of the agent, once the container stops, there we go, just stop. All I gotta do, Docker pull, that will get the latest. We've already got it. This gives us a new version. That's it. So basically, if you install Docker, do a Docker pull MTConnect agent latest. If you need to build for the compose, you can just do a Docker build as well. So that's, you can also get the demo if you want. Demo is just the twin demo, similar to what you get at demo.mtconnect.org, and doesn't have MQTT installed by default, but just again, Docker compose. Yeah, we'll start your demo right there. So that's about it for how to fire up MQTT. That's a current version that we have right now. We have also some new capabilities that we just added to the agent to support ingress. And I was going to talk to those as well. To check that out, actually, you can just look in the releases, a little bit of documentation for this release here. So let's say you want to, instead of using the standard MTConnect shutter adapter, if you're familiar with that, which is basically a timestamp and pipe limited data, the agent now natively supports JSON payloads coming in as well through MQTT. And they can subscribe to any topic you want. So basically, you just tell the agent that you want it to subscribe to some test, that you want to subscribe to, let's say, the ingress topic, anything under ingress. And that's all you want to do. Well, all you got to do is basically send over payloads that look like this, where you have a timestamp. So in JSON, a JSON object, you create a timestamp. And then these are all your data items. Either this could be the name or the ID, similar to what you can do in Shredder. And then the value. So in this case, A is execution, B is some numeric value, and so forth. You can also send over things like conditions. This is a fault, or messages. You can, if you have multiple timestamps, you want to bundle them all up into one publish, you can do that this way too, where you can have timestamps, an array of objects. Or you can specify, let's say you have one MQTT broker that's serving up multiple different devices, publishing to the same topic at the same time, or let's say one publisher that's publishing to multiple different devices at the same time. You can do it that way, like a sensor or something. So you can just specify the device and then the data items going into that device. We support things like all the time series, of course, data sets and tables, and so forth. And we also support assets as well. Assets right now have to be published in XML just as a string, but we will be doing the JSON version of that shortly. So that capability is now in there. Actually, I didn't even prepare this, but just why the hell of it? I like to take risks. We have time. Start 5 minutes early. Stuff I did for Neil. what I'm going to do is I'm going to run a I'm going to run a local version of Mosquito. I'm going to run the broker right here. There we go. Just started it. And then if I go back to this guy here, I'm going to disconnect. And I'm going to reconnect. There's nothing there. So now I'm going to debug this guy. So I was going to run it here. And now we have a local version of the agent again. And let's just go. Oops. Oh, wait. Oh, I said I didn't prepare this, so it was more interesting that way. Go. So this is just a simple device, not too much going on here. But what we're going to do is we are going to publish this guy. And you think I can pull this off? Good luck. Uh, Topic was ingress data. People remembered on that configuration file, which is ingress/star. And we're going to do a simple payload. I am just going to pull one of these data items. Let's do availability. How about? Let's see if we can set that to something. Make sure recording doesn't close anything. It's published. And it didn't work. Anyway, this may not work. Right? Then again, I need to spell things correctly. Often that is my main problem. There we go. By the magic, it just switched to available. So it did work. I just need to know how to spell ingress. So you can change, let's publish a couple of other guys here. Let's set the execution to active. So we just take like here, the execution, oops, and do that. And get fancy, slowly dangerous. Let's see. What else? We could set the position here, the absolute position to 1, 2, 3, 4. Push that. And now this guy's active, and this is 1, 2, 3, 4. So that's about it. So again, the current in version 2.2.0 to 15, in this version, we created this new capability. If you don't set the timestamps, it will just default to right now. So this will automatically be defaulted. I didn't think I could do that much typing without completely making a mess, but that's about all there is. So if you want, let's say you have a sensor out there and you want to use MQTT for ingress, you can now do that directly by just configuring up the agent as we show here with creating the adapter and the sync. And you can set also things like last will topic. There's a bunch of different things that can be configured with MQTT. So that, and they're all in the README that goes along with this guy. So here you go, MQTT configuration, the syncs. The second sync is we're using sync 2, which is the one we're going to probably deprecate the first one, but this is the second one. And you have all these options, things that you can set, the intervals and all that kind of fun stuff. So have fun, and you want to play with MQTT and MTConnect, please do. All works right out of the box. So I'll take questions on that. If anybody has any questions or comments on what I just showed.
Well, somebody sent me a question about plugin versus off the shelf, but are you going to present that separately?
Yeah, that's part 2. So if there are no other questions, then I will actually address that right now. So plugins versus off shelf. So Simon and I have been working on a set of plugins for the MTConnect agent. The MTConnect agent was re-architected recently to provide the capability to extend its functionality. And the idea was that we'll give a core set of functions like shutter, MQTT, ingress, egress, and various capabilities, but there's no way that the Institute can support all possible use cases and all possible ways that people want to use the agent, as well as sometimes it requires some licensing to do certain things with the data, such as some of the OPC UA, some other products and technologies. As well, we need to be able to allow people to work with the agent and do things that we didn't envision or we don't want to, support directly within the Institute. So what Metallurgy has done, we've created what's called the meta agent. The meta agent is assigned. We have a code signing cert on that. So it's a signed version of the agent that we put through some extra tests. It has a number of different plugins that we create. We have both plugins as well as gateways. We support OPC UA, NC Link, RethinkDB, InfluxDB, Elasticsearch, Apache Kafka, and now we're also supporting Sparkplug B. We'll do that demo next time. It's still in debate about exactly what the template structure is going to be in Sparkplug B, but we got a prototype out there and it's working on Ignition right now. So Simon's put this together. That's up and coming. What's not here is what I'm going to show today, which is a new capability, a new plugin that we just created and our gateway that can sit on top of any of these guys. And it supports Umati. So the difference between the built-in capabilities of the MTConnect agent and plugins is that whenever I release a version of the agent, it comes with a certain set of pre-built capabilities inside of it. They're all documented here, as well as we have documentation in MT Cup around this as well. And they support the core capabilities of the standard and what we talk about sort of as a normative, the XML representations, the JSON, the protocol, the REST protocol is all captured within the agent as well. Now we support MQTT as I just showed. That's all bundled into the agent that you can either build yourself download the pre-built binaries. If you go to releases, any release, these are pre-built binaries for Win32, Win64. For something like, let's say, Linux or Mac OS, we encourage you to just build them up. It's, if GCC is free, or Clang, it builds across multiple different platforms, and it's all fairly easy to do. If, let's say, you wanted to use Docker, again, Docker Hub, we have pre-built images on Alpine, and as well we support additional. If you go to the Docker directory here, we have additional information about building up the agent for Docker, and we have both Alpine and Ubuntu Docker files for both operating systems that we maintain. So that's kind of what we have out of the box. The Institute provides this. It has a lot of capability, and it's the full feature, full tested version of the agent that we maintain for the community. Above and beyond that, when you get into things like additional databases that we want to be able to support, let's say directly out of the agent, like you want to pump your data directly into Elasticsearch or RethinkDB or InfluxDB or something like that for time series, that's where plugins come in. So what we can do is third-party companies, like a company that Simon and I have, Metology, provide extensions to the agent. These actually can be installed directly into the agent or run as separate standalones. We provide both options. And when you fire up the meta agent, you can say which of these in your configuration file you want to use, and then it automatically starts those services for you, connects to the database in this case, or creates an OPC UA server, and then provides that particular capability directly from the agent. So I'll show you a little bit of that right now about how the plugins work. And we have a version of the agent running with all the plugins currently enabled. And that's right here at demo.metology.io. So I'm going to jump into a little bit about our plugins and what we do. This also is, of course, this is the twin demo as well. So, you can go here, and this is running the full twin demo. As you can see, things are changing and machines moving around. And you can view all this fun stuff here. So this is, you go to demo.metology.org, you can see all this stuff. And I'll show you also what that looks like in OPC UA. But what I want to do first is discuss a little bit about Umati. So there's a lot of confusion sometimes about what Umati is exactly. And talking with them is a combination of things. It's an organization that is producing a set of standards or companion specs for OPC UA, as well as this application and a set of requirements for the application to participate in it. So let's say you're a machine tool builder and you want to participate in the Umati app. Here we have the Umati app running. I can go to things like, these are virtual shows. This is a virtual fair that's running, and I can see the different machines that are at the virtual fair. These are all the machines that are up and running, as you can see. And then I can look at the various different machines. So let's say this is a machine tool. I can look at some information about it. That one's not too exciting. That's one's not too exciting. Let me try to find the one that's a little bit more interesting. So you have some basic information. This is what's called the this is like the identification portion. This is the nameplate, which has manufacturer, the software versions, product URIs, build information, and so forth. You can get into more detailed views about the machines as well. And there are some examples out there. Things have changed a little bit since yesterday. Doesn't make my life easy. So let me just all the machines. This is a CMM, so they have some different types of machines here. I'm trying to look for one that has more information associated with it. So let's go home and see if I can find more machines here that have interesting information associated with them. I think there was one down here from Mitsubishi. And here, okay. So the stack light information, we have Mitsubishi Electric, we have the nameplate information, we then have some tooling, info, active program, some information about the feed rate and operational modes, channel ones, and the spindle information. That's right here. So you have some very basic information as application, as well as the slope stripe chart that tells you when the machine was active and inactive. You can go to a slightly different single monitor view as well. So this is pretty much the set of data. So the next question is, okay, how do I know what information I need to provide to be able to support this application? And there are some materials here on the umadi.org app. So in umadi.org media, you can find, there's this sales brochure, which is really just an overview of what the organization is. There's a GitHub repository, which I'll show you in a second, and then the specifications. Specifications are really where you need to look. And if we look here, we can see the various different information. These are the node sets in the OPC Foundation that are required. This is the nameplate information here. That's what's called vendor nameplate. And these are the required fields: model, product code, software revision, year of construction, location, and actually the URI is also required. And then it tells you here how that information is mapped in there, as well as what that stack light thingy, this one doesn't have it, but if you provide it, what the stack light colors mean, and then various pieces of information, where they come from in the information model and so forth. So that's the Umadi application, and is showcased. Again, this is showcased at umadi.org specs, and you can get there from their media page. Another way you can get there, you can go to Umadi GitHub repo and showcase. And here you can find out information about it as well. So we can go to, like, let's say you want to find out about this dashboard. This is a dashboard bit. You can also say, tell me about the various different specs. If I go back up here to showcase, I can say, okay, I want to know about what I need for the machine tool. If you may notice this as we're going through this, this is exactly what we just saw. So the page that I just was showing you is actually just this page rendered with a white background, whatever color background you have on your browser. So that's where this is sourced from here. So there's additional information here as well. So you can have machine tool, there's software, there's work in progress, there's a bunch of these different things they have as these templates for various different machine tool or software types. As well, when you implement this, you're not sending data directly from your OPC UA server to the Umadi app. It goes actually through an MQTT broker using a special MQTT, a special JSON payload, and a special topic naming thing. So they provide software here for you for this gateway, and that's actually in the Umadi GitHub organization. So you need to install this gateway. I'm not going to show you how to do that. That's something that if you want to, you can integrate with them. And there's a bunch of other things you need to go through to sign up and so forth. So I'll leave that as homework. But basically, you build your OPC UA server, you build your gateway, it then goes to their broker and then up to the Yamati app. And that's the way it works. Now, the hard part is doing this thing here. This is all common software. They give it out for free. You set it up, you sign up with Omadi, we're off to go and running. But let's say you have MTConnect already running and you say, okay, how can I quickly get OPC UA up and running with the Umadi server and provide all of those tags that are required to be able to support this application. So how do I do that? And how do I get onto this showcase really quickly? And without having to read all of these specifications here, because these are all the specifications and they're all produced by VDMA. So if you go to VDMA catalogs, you can see all of these VDMA specs, and these are like, the OPC UA for machinery, and there's a bunch of others. Simon actually read a lot of these to understand how to put what I'm about to show you together. We went through that and started to do some of the mapping. There's still more work to be done, but I'd say it's adequate to support the application as it stands right now. So the first thing is MTConnect is basically a superset of the information that's required for the Umadi app and for Umadi in particular, in general. But there's a few things that they require, like in a nameplate, that aren't provided directly out of MTConnect. So, I say a superset of most of the data, but there's a few things for identification that we need. So what's happened is we've added a few pieces here, like the product instance URI. We don't have a URI in MTConnect for the instance URI. So right now, we've added that as part of the description of the machine, just as a sort of key value pair. And if you put that into your description, that will then populate properly in the Umadi app here. So that's required. And you can also provide some other information as well, such as your product code, again, the URI, location, and that will be the longitude and latitude. We have to put it in there. And then the device class. Again, that will populate here. So location, right? And your device class. This one's even undefined. So if you provide that information, we can, again, provide those tags. And that's, in essence, the way this thing works. So basically, all this description information gets populated back into the Umadi app. But the next thing is we have to map the MTConnect information model into the Umadi information model. And I'm going to show you that right now. So up at the server that we have running, demo.metology.io, we have all of these OPC UA servers running. And I put them side by side here just to show you a little bit of the differences. I'm just going to stop and restart this guy just to make sure that we have a fresh version, because I started this thing up yesterday. And it should be good to go. There we go. So a little bit of duplication here. So here's our object hierarchy. The Umadi stuff is under machines. MTConnect stuff is here. So if you don't know this right now, MTConnect also has companion spec, which is similar to machine field companion spec. We have it follows the MTConnect information model, the SysML model, very closely. So you have things like components, auxiliaries, axes, here are all of our axes, X, we have load, positions, feed rates, positions, all kinds of stuff in here, and so forth. And you can see the values right there. These will change. Of course, your actual positions, your position, there they are, and so forth. So we have all that information, as well as then your controller information and the paths associated with that controller, and so forth. So here's our path, and our active program, and so forth. So that's all of the MTConnect information. If you're familiar with the MTConnect information model, I'm not showing you anything new or different. The OPCUA companion spec is yet another representation of the MTConnect information model, as we do with, we have XML, REST, MQTT now, OPCUA, we're going to have Spark 1B, etc. They're just different ways of being able to represent our SysML abstract model in these various different top-level standards. And there's, for both the different devices, there's Kuma and so forth. So that's MTConnect. Now, Umati has the machine tool spec. So this is our plugin. Our plugin is producing both of these sets, actually in parallel. So with our plugin, you can actually turn on or off. You can either have Umati, MTConnect companion spec, or both operating at the same time. We've turned both on here. And we have both the MTConnect companion spec and the Umati companion spec all operating at the same time. So the MTConnect OPCUA server is providing both of these capabilities in parallel. So here is Umati, and I'm going to go through the same thing. So we have equipment has tools. So here's our tooling information. MTConnect has assets, and we have some information about it. And then, this is the locked flag. So if we pop back to here, we can quickly look at tool locked identification. So that's your tooling information, right? Nameplate, we talked about that. Asset ID, their component name, device class, location, manufacturer ID. Go back here. That's our nameplate right there. So all this information will populate there. And they then have a section called monitoring. Monitoring is broken down into channels. So this is kind of a PLC-centric way of looking at things. And you have things like your feed override, the channel mode, which will be, right now it's an automatic. That's similar to our controller mode and similar to different paths. And then your channel state, active, and those will feed into your monitoring section here. Okay. And feed override. Again, these kind of things. So that's your monitoring section. Then you have your machine tool itself, the operation mode of the machine tool, which is, I guess, the general machine tool mode versus the channel specific one. And then you have the various different spindle information. You don't get some of the telemetry that you get out of MTConnect. You don't get the positions and some of the other stuff, but you do get, your spindle information. Is rotating, is just whether it's rotating or not, and also what is used as axis. In MTConnect, we have the rotary mode, which tells you whether it's acting as a spindle or indexing or contouring, one of those three different modes. So this is basically when the spindle is in, or our rotary axis is in a spindle mode. It's not used as an axis. When it's either in contour or index, it's used as an axis. And is rotating as if the rotary velocity of the axis is greater than 0. So that's how we map that in. Again, spindle 2, same deal, spindle 3, etc. So that's this machine. I'm going through, again, these are our rotational axes. Some notification information, and then production. This is our active program. Again, going back here, active program, name of the program, state, and so forth. And again, name, and state, current state, and so forth. Right now, our machine is running. So that's the same as here, running ID, ID, and so forth. So that gives you that basic structure. As you can see, we have now mapped, and this is the first case that we were doing this thing, we have mapped all the data necessary for this application within the OPC UA plugin from Metology that allows you to drive this display from any MTConnect agent. And what we do is we basically take the information from the agent. We can either do this as a gateway if you have an existing agent, or we can do this as a plugin and embed it directly in the agent if it's 2.0 or later. Or that actually we can even replicate an old agent, let's say a 1.2 agent, and with a new agent and do it as a plugin as well. So we actually have 3 different deployment options with the meta agent that we can do to be able to provide with any MTConnect existing implementation the Umadi dashboard capability. More support, we haven't added additional support above and beyond what's required in, again, these specifications that I showed you before, the showcase specifications. We basically provided all of this information that's required and put it here. And as well, you also get the MTConnect information model as well, of course. And yeah, your basic information as well. So that's what we have done as an initial implementation. Again, we've just completed this bit of work and are licensing it to companies that are interested in a quick and dirty. I want to support Umadi and support some of the work that's going on there. So, I want to be able to peer, let's say, on this thing here and take part in, let's say I have a machine over here. I want to take part in their show and provide information from my equipment. If you want to do that in a quick and dirty way, this is one of the fastest way to get there. I see Eric has a question. Question 1. Are the mappings from the MTConnect to Umadi OPC UA companion spec available for review? The answer to that is not yet. We did this as an initial sort of project, just to provide something quickly to the industry. We did not document yet. We are discussing this with VDMA right now as a institute project to provide a full mapping document and companion spec that will basically, well, it's kind of like a companion spec, but it's basically, it's a co-production of the MTConnect Institute and the Umadi organization to do a detailed map of all of the information models from one to the other, and that will be blessed by both organizations. Just FYI, this is not blessed what we've done. This is basically Simon and I taking a look at the specs, reading the specs, and getting as much information as we can to provide this service to the industry. So we hope to engage with Umadi and VDMA in the short term to provide that, exactly what you're just talking about. And as private IP, the plugin is private IP. It is our licensed product. The mapping is targeting a public standard. So again, everything that we're doing is visible for complying with these node sets. So what we've done is we've actually used those node sets. So if you go even to here and you look at the types and you look at everything else, we are using the OPC UA companion specs that are given by the VDMA organization and are available up on the VDMA OPC UA Foundation website. So that's all just stuff that is available to us. Okay, another question from, okay, so one more comment. The subset of MTConnect data types necessary to support that mapping could be an excellent guideline, provide machine vendors a minimum. Yeah, that's true. And it is sort of a, again, we're working on that within the validation group, the set of data items that are required for particular use cases. This could actually feed into one of those use cases and drive that. So that's a really good point, Derek, related to this guideline. Let's see, Scott Wyatt just sent in a question. Will, can you talk a little bit about the path to surface MTConnect data through the OPAC UA surface? You mentioned the companion spec many times. Is there a community commercialized implementation? We had a gateway, but it's kind of a fairly old right now for doing the OPC UA companion spec. So, Scott, I'm not quite sure if you're asking or what question you're asking, but let's see. So the companion spec for MTConnect, we provided an open source gateway a little while ago, and it wasn't complete, and it was just more of an example of how to do it. It's based on the here it is. So it's under MTConnect. I'll publish this here. This was a open 62541. It's not really maintained. We developed it just as an example of how to do it. The one that we now support is an extension of this and provides it not just, this is just a gateway. In other words, it runs externally, does not run as a plugin. The one that we produce from Metallurgy is a full version that's maintained with the current version of the MTConnect standard. So there's some more capabilities within the gateway that we have commercialized that support some of the new data item types, classification. So we keep up with the versions of the standard as we rev it. So, all the way through 2.2, and we're going to support 2.3 as it comes out and everything else. And now our gateway also supports Umati as an additional feature. So I'm not sure, let's see, the path to surface MTConnect data through the OPC UA gateway. Architecturally, are you asking that question, or are you asking from a standards or specification perspective?
Hey, Will, I don't have a camera on here, but yeah, I was just, you answered my question.
Okay.
Yeah, through your IP, basically, your extension. Yeah, I guess the term gateway was a little ambiguous to me, but scrolling through the GitHub that you had there, understand that's an example, but the current implementation, the way that you would do that is to use your plugin, private plugin.
Yeah. Now the gateways themselves, so our plugin can actually run also as a gateway. So we have both options available to you. The gateway version of it is just an external process. So you have the agent, and then next to the agent, you have a separate process that's running that reads data from the agent and then republishes it using OPC UA. And that's if you, let's say you have a legacy gate implementation of MTConnect, you haven't upgraded yet to 2.0. So let's say you're still on 1.8, but you still want to use OPC UA, but you don't want to upgrade the agent on your machine today. So what we can provide for you is a gateway, which is a separate process that could run on that machine and provide the same capability, basically the OPC UA data out of that older agent. That's why it says 1.4 plus. The new MTConnect agent with 2.0, you can run it basically as a single unit, so you don't have to manage multiple applications, so you don't have to manage your adapter, your agent, and your gateway. You can just manage your adapter and your agent, and you're good to go. So it reduces the complexity of the deployment by a process, and it will basically, it's running embedded within the agent. So it's a little bit easier to deploy as a single unit. And pretty much from a configuration standpoint, all you do is you just say, in your config file, you say, if you have a license, you just put a license key in there and you say, okay, turn OPC UA on, and magically you have OPC UA coming out of your agent as we do here. So it's just a matter of, once you flip that switch, that you get OPC UA. We'll have another switch that you can flip fairly soon that you can say, I want Sparkplug B. Well, okay, flip on Sparkplug B, and again, you have Sparkplug B coming out of your agent. So just configure it up, and you fire that guy up, and you can do actually any of these. If you have somebody asking for NC Link, we can do that too. So you can provide MTConnect with the REST interface, MQTT, as I showed before, that's available always, OPC UA, Sparkplug B, any of those combinatorial. So the objective that we have here, and this is a general objective of the agent architecture, is any way that somebody wants to consume data from MTConnect, we can support. So basically, we have our MTConnect model. Our model provides, if you look at, again, this was mentioned earlier, but this is our model. Actually, preview the new one that's coming out soon. It's our 2.3 model. All of our information is really this. It is our model. Shara maintains this. It's our component hierarchy. It's our observations. It's the way that we structure the data. What we can do now is we can actually present that in many different ways. We have these representations we can create now, and we have XML and JSON representations of many of the different information model or information entities that we have within MTConnect. Eventually, we're going to have here too OPC UA and Sparkplug B as sort of supported representations. So this is kind of a preview of where we're going with this. The templates, the way that we take our model and project it into the various different standards that are supported by the Institute, our OPC UA companion spec, our Sparkplug B companion spec that we're working on right now with Eclipse and Arlen Spector and some other folks out of that group, out of Sparkplug B. All of that stuff becomes effectively projections of this model. So when we talk about this, we're talking about how either provided directly out of the MTConnect agent as a sort of a publicly available open source capability, or the other capabilities that you can provide out of from third-party vendors. Again, we're just one. these are all things that the Institute and the concept of MTConnect wants to be able to support. So basically projecting that model into these various different representations. So I'm not sure if that cleared things up, but it's sort of a philosophical direction that we're going.
Yes, thank you. Could you share some of your like guiding thoughts or principles on what the Institute would be willing to take over as far as, all these different plugins that are listed on your screen share there is current private IP, MQTT being one that stands out as, that's outside of the REST API that's been around for a while. So the Institute is sponsoring MQTT. Is there any thought that that list would expand in the future, or pretty much stay there
Yeah,
and leave the third parties to support other protocols?
again, it comes down to funding, and the Institute has limited budget for software development. I can tell you, as being the primary contributor to the agent, that there's a huge amount of work that goes into maintaining the subset of capabilities that we have right now in the MTConnect agent. I mean, we're very active as far as the amount of changes. Like I just pushed another release yesterday, which has some new MQTT capabilities in it. You can see there's almost every day there's something going on. So basically, very active open source project. Takes a lot of my time and a lot of resource to maintain this. We have about 4 or 5 contributors now. Just managing that set is the limit of what we can do through the Institute at this point. Again, if third-party companies would like to fund activities within the MTConnect Institute to support additional capabilities within the core agent, we're open to that. We did this mainly because we just need a way to be able to also pay for some of the work, like doing this OPC UA Umadi capability was, I say not free. It was a lot of effort to put that thing together and to do to do all these gateways and everything else, and even the Spark B implementation. Working through the different specs and everything else. So, in short, yes, the Institute could take over more of these plugins and more of these capabilities, embed them directly into the agent. But again, we need to find ways through the community to support those activities.
Makes perfect sense. Thank you.
Okay. Other questions? Alrighty, I think we got about 2.5 minutes left or so. If there's no other questions, then I will turn it back to Russ. And thanks everybody for listening to me.